In this video, we'll be looking at the graphs of exponential functions. An exponential function is of the form f of x equals b raised to the x power, where b is a positive real number. Let's first look at the function y equals 2 to the x. If x is negative 2, we have 2 raised to the negative 2 power. Recall that a negative exponent makes the expression 1 over. So this is 1 over 2 squared, which is 1/4. 2 raised to the negative 1 power will be 1 over 2. 2 raised to the 0 power, we know that anything to the 0 power is 1. 2 raised to the 1 is 2. And 2 raised to the second power is 4. So this curve, when x is negative 2, y is 1/4. When x is negative 1, y is 1/2. When x is 0, y is 1. When x is 1, y is 2. And when x is 2, y is 4. Now, if we did x is 3, we would have 2 to the third power, which is 8. We have that on our graph. We can go up to that point. So we can see that our graph of our function has an asymptote at y equals 0. This is never going to hit the x-axis. And we can also see that it increases rapidly. This is an exponential growth curve. Our domain is not restricted, so all real numbers. And our range, we can see that we start at 0, but we don't include the 0, and we go on up to positive infinity. So our range does not include the 0, and then goes up to positive infinity. Now I'd like to also look at y equals 3 to the x power, just to compare it to the 2 to the x. When x is negative 2, we have 3 to the negative 2, which will be 1/9. When x is negative 1, we have 3 to the negative 1, which is 1/3. When x is 0, we have 3 to the 0, which is 1. When x is 1, we have 3 to the 1, which is 3. And when x is 2, we have 3 squared, which is 9. Now, let's plot these points. When x is negative 2, y is 1/9, which is a smaller number than 1/4. So it's between the red curve and the x-axis. When x is negative 1, we have 1/3, which is a smaller number than the 1/2. When x is 0, though, y is 1, so we have the same point on both. When x is 0, y is 1 for both. When x is 1, y is 3. So this time my y value is bigger than the y value here at 2 to the x. And then when x is 2, y is 9. So that's bigger. So our curve is between the y equal 2 to the x curve and the x-axis until we hit x equals 0, and then we get bigger, and it's between the red curve and the y-axis. Now I'd also like to look at y equals 1/2 raised to the x power. We put that right here. Y equals 1/2 to the x. When x is -2, we have 1/2 to the -2 power. Well, when I square 1/2, I get 1/4, and the negative exponent flips that, so it becomes 4. When x is -1, I have 1/2 to the -1, which is just 2. When x is 0, I have 1/2 to the 0, which is 1. When x is 1, I have 1/2. And then when x is 2, I have 1/4. Let's graph these points and see how this base that's a fraction compares to the whole number base. When x is -2, I have 4. -1 is 2. 0 is 1, so again they share that same point. When x is 1, y is 1/2. And when x is 2, y is 1/4. So this time our curve looks like this. This one is an exponential decay curve. But you see that the domain is still all real numbers, and the range is still from 0 to infinity, not including the 0. And we still do have an asymptote at y equals 0.